Hello, my name is Hui, and today I'm going to talk about my primary research, which is about designing and deploying the federated learning system in AWS environment through AWS CDK. And let's go to the introduction. So, in recent years, many advancements in machine learning open new breakthrough across various fields, and these advancements has enabled researchers to uncover new patterns and make more accurate prediction and innovation across numerous applications. However, traditional machine learning approach faces limitation because of the need to centralize data collection, which is raise significantly privacy concern and logistics challenges because it have to deal with sensitive and proprietary data. To address this issue, federated learning was introduced by Google in 2016, and this approach focus on decentralizing the training by keeping the data on the local devices and only update the model parameters to the central server. So because of that, this has proven advantages for training large and sensitive data sets such as medical and financial information while maintaining the data privacy. And but despite of the advantages, further learning also introduced new challenges such as communication overhead, device heterogeneity, and privacy concern. Therefore, efficient communication protocol, fault-tolerant frameworks, and differential privacy technique are needed to address these challenges. And the cloud infrastructure is crucial to implement the federated learning system because the cloud, in particularly, I'm using AWS cloud, offers scalability, resource accessibility, and robust integration capabilities. And AWS Toolkit which is AWS CDK, helps deploy and maintain the federated learning infrastructure efficiently and addressing the challenges of distribute the training and coordination. For the problem statement, the federated learning enables training machine learning across decentralized data source while preserving privacy. However, implementing this system have many challenges, and therefore, this research aims to integrate AWS CDK to create a scalable and secure infrastructure for the federated learning system, ensuring that data privacy and secure communication. And these are my objective is to design and implement the scalable federated learning system using AWS CDK and develop a communication protocol and dynamic resource algorithms, enhance data protection using some advanced security like differential privacy. And my approach is using the uh, flower framework. Its methodology is combining flexibility with AWS robust infrastructure capability. So this architecture involves creating the infra in the cloud, and I would train the data on my local device, and all the infrastructure for deployment will managed by the AWS CDK, and the tools are AWS CDK for infra setup, Flower framework for federated learning simulation, Python for coding, and AWS CLI for configuration and deployment. So in the picture, I have my EC2 instance. I will deploy uh, the gRPC server. It will act as a central server for training. I call it the chip node. It will train and store the data into S3, and the client node will be my current device. I will send the data to the load balancer, and these will be the logs will be stored in CloudWatch. And for the dataset, I'm using the CFA10 dataset for data processing and performing evaluation. And the dataset is partitioned by 80% for training, 20% for testing, evenly distributed among the client nodes. And these are my results. So after the simulation, I across three client nodes, I have a gradual improvement of accuracy through successive browse and routes, and demonstrating some effectiveness of further learning in distributed data for robust model training. You can see that these are over the route. The accuracy keep improving. And let's go to my setup. So let's talk about the code. So all of my code, most of the codes are in here. The infrastructure for creating the VPC, and then create a cluster with the security group. Then to launch the EC2 instance, I need to define the auto scaling group to scale based on based on like the demand. I'm using T3 large, so it can process my files, my models efficiently. And uh, I I created this method called add web gRPC control container. So it will use it will create a Docker image under the web folder. So in the web folder, I have um, my gRPC server. It using the Flower framework under the hood. It to uh, set up the central server, and my client and server will communicate with each other through gRPC bidirectional connection. And I created a logs group, so it will logs the data into CloudWatch. And that pretty much it. And then you can uh, let's go to the server. In here in the app, I set up uh, the gRPC and open to the uh, port uh, 5000 uh, 5051. I have to create the health check for gRPC. For load balancing, it need to check to see if the service is healthy or not. So I have to create a health check. Therefore, I have to set up my Nginx reverse reverse proxy server. So it will listen to gRPC HTTP2 connection, and if it held, then send it to the health server. If it's not, then send to gRPC server. And let's see is how it's being deployed. So in here, I deploy my after deployment through uh, my CLI. I This is my what I got. I got the VPC. Within this VPC, it define a couple of subnets, and I have a route table. And with the route table, I enable the internet connection via internet gateway. And this is my load balancer. It connect over port 80. And this is my EC2 instance. It's running, and I can access this EC2 instance. It's over here. Uh, with this, it will provide me the public IP address, uh, so I can oh, probably not this one. Uh, but with the EC2 instance, I will be able to access via the gRPC and the server via this public IPv4 address, and I save it into my client. As you can see, I updated my client, and then I just ran the commands to train locally, and to update the model of the server. So after it trained, it will send data to the server, and I get the data via the CloudWatch. I can see the result of the training in number of rounds. You see the accuracy getting improved over time, and that pretty much it.